Welcome to the world of load balancing. Load balancing is the process of efficiently distributing network traffic across multiple servers. This ensures that no single server is overwhelmed, optimizing resource utilization, and improving overall application responsiveness. In essence, it's about making sure the workload is shared evenly. So, what exactly is load balancing? It's a technique that distributes incoming network traffic across multiple back-end servers. The goal is to ensure optimal resource utilization, maximize throughput, and minimize response time. Think of it as a traffic controller for your server infrastructure, preventing bottlenecks and keeping things running smoothly. A key point to remember is load balancing distributes incoming network traffic. Why should you care about load balancing? There are two key reasons: high availability and improved performance. High availability means that load balancing eliminates single points of failure by distributing the workload across multiple servers. If one server goes down, the others can pick up the slack. Improved performance refers to reducing response time and increases throughput by optimal resource utilization. Load balancing ensures that users get faster and more reliable service, no matter what. Let's delve into load balancing algorithms. The first one is round robin. This distributes requests sequentially across all available servers in a rotation. The second algorithm is weighted round robin. With this, assign different weights based on server capacity and performance. Servers with higher capacity handle more requests. Let's explore some more advanced load balancing algorithms. First is the least connections algorithm. This routes requests to the server with the fewest active connections at that moment. Then there is the least response time algorithm. This directs traffic to the server with the fastest response time and lowest load. So the best performing server gets the next request. There are mainly two types of load balancers: Layer 4, that is network, and Layer 7, that is application. Layer 4 operates at the transport layer, routing based on Internet Protocol addresses and ports. Whereas Layer 7 works at the application layer, making decisions based on hypertext transfer protocol headers and content. So Layer 7 load balancers are more intelligent and can make more informed decisions. Health checks and automatic failover are essential components of load balancing. Health monitoring continuously monitors server health through periodic checks and removes unhealthy servers from the rotation. Automatic failover automatically redirects traffic to healthy servers when failures are detected. This ensures continuous service availability. Now, let's take a look at a simple round-robin load balancer code example. We'll start with importing the random module. Then define the load balancer class with the init method that takes servers as an argument. Then, getServer method is defined that returns a server. The code implements a basic load balancer that rotates through a list of servers. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.